Today. Before today, your math has just been in the real number system. So just talking about real numbers before today. So now we're talking about complex numbers. So with complex numbers, it's because we have imaginary values. So the imaginary numbers come from when you have a negative inside your square root. Whoever phone it is, please turn that off. Thank you. So your square root of -1, that is your imaginary value I. So looking at A, so think about if I have the square root of -4, think about that's really like two different parts here. That's really like, if I was to simplify it, that's thinking about me simplifying the square root of 4 and me simplifying the square root of -1. So what would just the square root of 4 be? 2. And what do I now know the square root of -1 is? I. So this is equivalent to 2i. So think about what you were just doing on that warm-up. Think about that simplifying that square root of like 27. 27 would break down into what times what? 9 and 3. And then I still have that square root of -1. So the square root of 9 would become 3. And I have root 3. So in math, we have grammar, so we write it as 3i square root 3. So your I is going to kind of be in front of the radical. So we have the square root of -28. Why don't you guys take a second, try and think about what that would be.
Whose phone is that?
Whose phone is that? Turn it off. It's okay, just turn it off. Alright, so what did we get? So 28 can break down into what times what? 4 and 7. And then I have the square root of -1. So altogether it's going to become 2i root 7. So let's look at our next couple of questions with our radicals. So let's look at the difference between A and B. So thinking back to our order of operations, what is question A telling you to do first? Multiply. So think about with your order of operations with parentheses, exponents. So think about with parentheses, kind of that is with all of your grouping. So think about that means do everything underneath your square root first. So we would just have the square root of 36, which would give us 6. But that's totally different than B. So B is saying to, so if B is saying to do that exponents first. So what I mean by exponents, that means reduce your radical first. So if I'm to reduce the square root of -4, what does that become? 2i. And what is the square root of -9 become? 3i. So I have 2i times 3i. So what would that become? 6i squared. So let's talk about I squared. So I know the square root of -1 is I. So let's think if I square I, that's going to be the squaring the square root of -1. So what happens when you are squaring a square root?
Just I cancel.
They cancel out. So if this square root and this square kind of cancel each other out, what's all that's left? -1. And so I squared is equal to -1. Oh, yes, so it would be -6, because this is 6 times negative 1, which is negative 6. Good.
Wait, so just say 6 and don't put that.
Right, so there's no more I here because I squared is the same thing as what? Negative 1. So basically, if you ever have I squared, you're not leaving it as I squared because I squared is reducing, right? Think about fractions. You always got to reduce your fractions. Or like your radicals, right? You reduce your radicals. Think about this is reducing a radical. That's I squared is the same thing as negative 1. So we're just always going to have it become negative 1. So let's check out C. So once again, let's simplify first. So what would the square root of negative 8, all of that simplify to? Yeah, good. 2I root 2 times another 2I root 2. So once again, multiply those outside values. So 2I times 2I would become 4I squared. What's root 2 times root 2? Oh, the square root of 4, which would become 2. Good. So once again, I don't want to write I squared. I want to simplify it. What does I squared become?
Negative 1.
Negative 1. So this is really 4 times negative 1 times 2, which is equivalent to negative 8. Cool, right? Yeah? So, when you have your complex numbers, kind of, once again, thinking about our math grammar, we always have a real and an imaginary value. So when we have, within our complex numbers, we have a real and imaginary value. So you always write your real value first, and then your imaginary value. So let's think about questions 1 and 2. So adding and subtracting these is just like combining your like terms. So thinking about 5x plus 10. Can you combine 5x with 10? No. So am I going to be able to combine 5i with 10? No, I would just, as simplified as it could get, 10 plus 5i. So thinking about from here, question 1, what kind of would be our first step here? Not FOIL, but yeah, just you can distribute this negative, so you would have negative 8 minus 9i minus 7 minus 2i. So now think about just combining your like terms. So negative 8 and negative 7, combining those together would give you negative what? 15. Negative 9 minus 2i would give us negative 11i. Why don't you guys try 2 on your own? And then, yeah, you just leave it after that. Think about why. They are not like terms. We can't combine them anymore. Try 2 and then see if you can kind of predict what might happen with question 1 next real quick. So looking at question 2, what did you find with question 2? Who wants to help us out with this one? Aubrey, you want to try it?
Yeah. So 5 minus 3i. Wait, I did the thing. I distributed the negative 12. The negative
Oh, okay.
12.
So you just
5 minus 3i. Do you want me to say the answer right
yeah, just the answer
Okay.
works.
9
Okay.
minus 8i. is what I thought.
9 minus 8i. Is
Yeah.
that good with everybody? Yes. Great. So what do we think might we do with question 1 next? Distribute. Good. So this would become
15 minus 30i.
15 minus 30i. Great. All right. So let's check out number 2. What does number 2 look like it's set up for you to do? FOIL, yeah, kind of go through and FOIL. So let's go through this one. So my first times my first term would give us negative 12. Then we would have our last, which would become 8i, outside. Then our inside would become plus 27i, and then my last would become minus 18, and then it would become what? I squared. So, we don't leave it like this, right? We like to simplify our expressions all the way. So let's talk about what's happening first. Remember, I'm simplifying. I squared becomes what? Negative 1. So this minus 18i squared is really turned into, good job, plus 18. So let's keep going and simplifying our expressions. That negative 12 plus 18 would give us, negative 12 plus 18 would give us 6, and then 8 plus 27i would give us
35.
Alright, so let's check out number 4, and then you'll try 3 on your own. So number 4, well, it's 5 plus I, and it's all squared. So what should I do? Yeah, I should FOIL, but first let's write it out side by side. Remember, something back times itself is something squared.
And then we FOIL it.
And then we FOIL it. So let's see, when we FOIL it, we would have 25 plus 5i plus 5i plus I squared. And once again, we have to keep simplifying. And what's going to happen with our I squared?
Just negative 1.
Just negative 1. So 25 minus 1 would give us
24 times
24 plus.
10.
Good. Try number 3 on your own while I keep checking some homework. Okay, so bring it back together.
Oh God.
Who wants to help us out with number 3? What did you find the answer to be in number 3? What was that, Kelly? 11 minus 5i. Does that work for everybody?
No.
Plus?
Yeah. Ooh.
Do we want to go through it, or are we all? No problem. All right, so let's keep the fun rolling and look at our powers of I. So we already know that I is the square root of negative 1. That's going to be like our base behind everything, knowing that I is the square root of negative 1, and that I squared is negative 1. So those are our bases behind everything from here. So we know I squared is negative 1. So if I want to figure out I cubed, I'm going to think about rewriting I cubed in terms of I squared and I, because I already know what those two are equal to. So let's think about it. I cubed is just I times I squared, right? We all know our exponents rules, like I times I squared, that'll give me I cubed. So let's think. I squared is really equal to what? Negative 1. So this is negative 1 times I, negative I, yeah. So think about this is like simplifying these powers. I to the 4th. I to the 4th could become what times what? Yeah, I squared times I squared, that would work. And what's I squared? Negative 1. And what's I squared? Negative 1. Sorry if you were answering a different question. So negative 1 times negative 1, that really gives us an answer of positive 1. So let's keep thinking about that. So I to the 5th, that would become I times I to the 4th. Well, I already know I to the 4th is equivalent to what? 1. So 1 times I is just the same as just I. So let's think about I to the 6th. So I to the 6th could become what times what?
Negative 1 times negative 1.
So don't get ahead of it. Yeah. it could become just in terms of I.
I'm getting ahead.
Like I times I to the fifth, right? So what is I to the fifth the same thing as? I. So this is really I times I, which is I squared. What do I know I squared is equal to? -1. Yes, it's going to keep going on and on and on. So I to the 7th is going to become I times I to the 6th. What do I know I to the 6th is the same as? As -1. So -1 times I is -I. I to the 8th. What could we rewrite I to the 8th as? What times what? Good. I times I to the 7th. I to the 7th is what? -I. So I have I times a -I. So this becomes a negative I squared. I squared is -1. So this is negative times a -1, which is 1. Does anybody notice anything? Yeah, it's a pattern. It's repeating in fours, right? It goes I, -1, I, 1, I, -1, I, 1. So, do you have to do all that work every time?
Yeah.
No, there's going to be a shortcut. Because that's what makes math so cool. So you are going to think about it goes in like sets of 4, right? So let's think about if I just had I to the 5th and I was trying to figure that out. So think about dividing it by 4. 4 goes into 5 one time, right? With 1 left over. See that 1 left over? That remainder of 1 means it's the same thing as I to the first power. 5 is the same as I. So think about 6. 4 goes into 6 one time with a remainder of 2. Or having a remainder of 2 is like having I to the second power. What's I to the second power equal to? -1. 7. 4 goes into 7 one time with a remainder of 3. So when your remainder is 3, that's like being the same as I to the third power, which is -I. And lastly, if you go into 4 evenly, so there's no remainder, what you're equal to 1. So let's look at some examples here. So if I was doing 13 divided by 4, what's my remainder here? 4 goes into 13 how many times? So why are we dividing by 4? Good question. Remember, this goes into like sets of 4, right? It's repeating itself over 4 each time. So if you can divide that exponent by 4 and figure out what the remainder is, it's going to be, if its remainder is 1, it'll be the same thing as I to the 1. Remainder is 2, same thing as I squared. Remainder is 3, I cubed. Remainder is 4, or sorry, if there's no remainder, that's the same thing as I to the 4. So, what's our remainder? So think about 4 goes into 13 how many times? 3 times with a remainder of 1. So if my remainder is 1, that means I'm the same thing as I. So 46 divided by 4. How many times do we go? 11 times with the remainder of what? 2. That means we're the same thing as I squared. I squared is
2.
I squared is -1. That's what I'm saying. I squared, second power. Yeah.
So like, when you do like 4 goes into 13 3 times, like what happens to the 3?
That's just me saying like 4 goes into 13 3 times, right? 4 times 12. I have to get 1 more to get to 13. That's helping you figure out your
So
remainder.
why can't we use like 8?
What do you mean? Because it's not repeating in groups of 8, it's repeating in groups of 4.
So as
Yes.
you go, so just remember that 1, 2, 3,
You always divide by 4?
Yes.
Yeah.
You're always dividing
Every
by
time.
4. Just remember that first set of 4, and then you'll be A-okay. So think about 23. If I'm dividing it by 4, goes into it 5 times with the remainder of 3. Good. So remainder of 3, that's like being the same thing as I to the 3rd power, which is equivalent to what? Negative I. So I to the 16th. Do I go evenly into 4?
Yes.
Yep, so that means the same as I to the 4th, which is equal to 1. Alright, how are we feeling?
as long as we just remember
When it's a
this.
remainder of 0, what is it?
Remainder of 0, that means it's the same thing as I to the 4th power, which is equal to 1. Yep, so remember your remainder of 0 is I to the 4th power, same thing as 1. So if you're ready, flip to the next page. So our conjugate, is like our complex numbers. What do you notice about a conjugate between here and here? What's different about those two? The sign in the middle is just, if you started off with a plus, then your conjugate would have a subtraction sign. So notice those A and BI terms are staying the same, just that sign in the middle is becoming its opposite. So if I'm given 4 minus I, what's the conjugate here? Yeah, 4 plus I. Those values stay the same. You're just changing the sign in the middle. So let's multiply these two, and then we'll kind of talk about why the conjugate is so important. So we have 4 minus I times 4 plus I. So going through and multiplying with our FOIL, we would have 16 plus 4I minus 4I, and then it would become minus I squared. Good. So that 4I and minus 4I, those become what? 0, right? Those cancel out. They become 0. This I squared becomes what? Negative 1. So I have minus a negative 1, which really becomes plus 1. So this is going to change into a plus 1. So this is really equal to 16 plus 1, which is what? 17. So this is why our conjugate is so important. We just multiplied by 2 complex numbers and got a real number. So that's the purpose of our conjugate, is we don't like having square roots in our denominator in math. Think about, what is I? I is really the square root of negative 1. So if I have I in my denominator, that's actually like having a square root in your denominator. So we're going to multiply expressions by our conjugates to get rid of any i's you have in your denominator. So let's just kind of figure out what the conjugates are, and then you guys can multiply them through. So if I have 2 plus 8i, what's that conjugate? Okay, 2 minus 8i. What if we just have negative 8i? What's that conjugate? Yeah, positive 8i. Think about this number that's secretly here, your real number. That's secretly there, 0. So like 0 plus 8i, so just a positive 8i. So So take a couple minutes. You guys can try multiplying those two on your own. Alright, so let's go over the second ones. Who would like to help us out with the second one, what they got? Kelly, what'd you get for the second one? 68. Good. So what should have happened was you should have done 4 minus 16i plus 16i minus 64i squared to get you 68. Then what about our next one? What did we get for that one? 64. Good. So in general, if you have two conjugates you're multiplying by, what do you guys notice? Kind of maybe look at this first example here to kind of help you see the pattern. So if you have those two things multiplied together, what is that always going to equal? Think about how we got 17. What do you think, Luke?
A squared.
A squared plus what? Okay, so looking here, we have our a squared plus, so here your a squared was 4, or your a was 4, right? So a squared was 4 times 4, which was 16. Then think about it, in this case it was 1, that was your what term? Your b. So think about 1 times 1 gave you that, like, obviously 1 squared for 1, and it was positive, so adding 1, that's how we got 17. So your conjugate's always going to be equal to your a squared plus your b squared, yeah. So if you're able to see that quick connection, then you're welcome to use it. If you're not able to see it, that's okay. Just take a second and write it out and multiply them through.
So can we just use 12 and multiply them?
Perfect. Yep, that works. But if you if you see it, then you're able to just use that as well too. So why we're doing this once again is we don't like having those complex numbers in our denominator, because that's like having a radical in your denominator. So we're going to multiply. Think about, once again, we're going to multiply by our conjugate, so that way we have a real number in our denominator. So what would our conjugate be here for a, for the denominator? 1 plus 2i. So remember, I don't want to totally change the expression I'm given. I need to be multiplying by 1. So I also have to be multiplying by 1 plus 2i in my numerator. Same thing in my numerator and denominator, that gives me 1. So let's multiply through, see what happens. So thinking about our numerator, foiling through, we've got 5 plus 10i plus 3i plus 6i squared. Thinking about our denominator, that a squared plus b squared. Our a squared would become 1. Our b squared would become 4. So let's keep simplifying. So simplifying your numerator, I squared, what will that become? -1, so this is really a minus 6. So in my numerator, doing my real terms first, 5 minus 6 would give us -1. 10i plus 3i would give us 13i, all over 5. So let's look at C together too, then you guys can try B and D on your own. So for C, what is that conjugate of that denominator? So remember, just that middle sign changes. It's not a positive 3. It's going to stay a -3. and it'll be minus 2i. So looking at our numerator, boiling it through, we'd have negative 6 minus 4i minus 27i, and then minus 18i squared, all over 9 plus 4. How we get 27? 9i times negative 3. So this I squared is going to become, I squared becomes negative 1. So this is a minus 18 times negative 1, which would become a plus 18. So adding those real values first in the numerator, negative 6 plus 18 would give us 12. Good. And then negative 4i minus 27i would give us all over 13.
So you just want to get a real number?
Yes, good. So remember, the purpose behind multiplying by your conjugate is you just want a real number in the denominator. That's why we're doing it. So try B and G on your own. All right, so in B, what were you multiplying your numerator and denominator by? 1 minus I. Good. 1 minus I over 1 minus I. So going through really quickly, you should have 2 minus 2I minus 7I plus 7I squared all over 2. So,
Yeah.
in the end, what is your numerator going to become?
Negative 5 minus 9.
Good, negative 5 minus 9i all over 2. So checking out D, what is the, what should you be multiplying your numerator and denominator by?
4.
Negative 4i over negative 4i. So your denominator is going to become 16, and your numerator would become negative 12i, and then what? Plus 4. So once again, we like to have our real values first.
We didn't know what I meant.
So I 4 minus 12i over 16. Does anybody notice anything about this right here, though?
Yes.
You can simplify all of these values by what? 4. So yes, you should be simplifying. Think about it like a fraction. You should simplify it. So that would be 1 minus 3i all over 4. All right, so let's check out what we're going to talk about next. So this stuff here is kind of more of like a glimpse into future math classes. More so what you guys will be like tested on and like quizzed on. What's your quiz again? Next class. Good. So remember what your quiz would be on. Are we all listening?
Yes, ma'am.
Thank you. So remember what you're kind of going to be quizzed and tested on is, it's not going to be kind of what's on this page. It's going to be what we've just been going over, like kind of like the simplifying and evaluating. This right here is just kind of a connection between geometry, what you've kind of done before. So, all right, stay with us. So you normally had your Cartesian plane and your real plane with your x and your y-axis. So if I'm talking about imaginary numbers, they have an imaginary complex plane where your real axis is like your horizontal, like your x, and your imaginary is like your y-axis. So any point or any value you have, like if you had 8 plus 6i, think about 8, that was your real. That means you have kind of like an x value of 8 and a y value of 6. So notice if you wanted to take the absolute value, that means finding the distance from where? 0, or like the origin. So if I'm at this point here, 8 plus 6i, and if I want to find the absolute value of that, or the distance from the origin, think about I'm finding this right here. What do you notice this looks similar to from geometry? A hypotenuse, right? And that's your right angle. So what did you use in geometry to find, if I knew this was 6 and I knew this was 8, what did you do to find
A squared
this?
plus B squared equals C squared.
Yeah, good stuff.
With,
So
yeah.
to find the absolute value of that, or that distance from 0, you're just doing that Pythagorean theorem. So, thinking about finding this guy here, that absolute value of that complex value, that distance from 0, you're taking that square root of your a squared term, which was 8 here, plus your b squared term, which was 6 squared. And that should give you the square root of 100, right? Which is 10. So that's just kind of a connection from the past. We can kind of go over plotting one point together, and then what you guys are going to do is you're going to actually do the back page, because that's more practice that I think your time will be better spent on. And then if you finish that back page early, then you'll come back and do the rest of these. So look at 3. So think, no, I already said no. So looking at 3, you have -1 plus 4i. So thinking about putting that, -1 is like your real value, right? So thinking about real value is on my x. So think about -1 on my x. And then 4i. 4 is like my imaginary, that's like my y. So that would be this point right here. So, as a reminder, you're not being tested on this stuff, but it's kind of a good connection from future to future and like from your past math class. So, thinking about from here, if you wanted to find that absolute value, that distance to 0, once again, you can do this,
Right?
the Pythagorean theorem, right? We just talked about that. Remember, that would be -1 squared plus 4 squared. So that would just be root 17. So you can do this if you finish that back page early. So for the rest of the time, work on that back page. Remember, you're going to have a quiz next time on complex numbers. Don't be too concerned with this. It's just a good connection. Yes?
So is this gonna be on our test?
Yeah.
No.
No.
No, so we don't have to really like worry about it.
That's what I was just saying. In a
Most things.
not as direct way as that.